Hi everyone, this is Synthopotamus. Today I will provide an update on PCP, also known as the Pascal Clock Prototype. During this presentation, we will explore the key findings of Phase 3, primary accomplishments, plans for Phase 3.1, and some updates to the overall architecture of the project. Without further delay, let's get started. Phase 3 had one primary goal: port the PCP procedural C implementation to a C++ solution. This process involved untangling a significant amount of code to derive a reasonable object model to base the future work of PLP and PSP on. Confounding this effort was a heavy reliance on global primitive state arrays that I had been using to allow for rapid prototyping. Pretty much all of the code was entangled with these global variables. Picking it apart was tedious work. Ultimately, I was able to divide everything up quite nicely into a few main classes. These include MIDI, storage, keyboard, network, composition, and view. Abstracting to this new model allows for a clean separation of functional concerns as we move forward with new feature additions. One main concern about moving to C++ was performance. I am happy to say that I was able to maintain performance by implementing the composition class as an asynchronous state block. In simpler terms, the data for any song is always accessible to all parts of the program without any restriction or synchronization requirements. This keeps performance up and avoids lag or delays when using the program. In this diagram, you can imagine the black box called View as the display of the program. The blue controller box is the user interface that allows you to do stuff with the program. The green model box is the data that represents your song and what you are currently doing with the program. Most often, the View and controller classes will work with the model data that represents your composition or song. The red MIDI and purple storage boxes also work with the model and composition data, but a bit less often, only interacting with it when the user issues a command via the controller to play back, edit, or save the composition data. In simple terms, think of the data for your song like notes written on a big chalkboard that everyone can see, erase, change, and use. That is what the green box is like for all of the rest of the boxes in the diagram. It is a big chalkboard that View, controller, MIDI, and storage all use to help you record and play back your song. Like sheet music being read by different people in an orchestra, except in this case, the players in the orchestra are computer programs. To implement linear sequencing, we need a way to record when a note is activated and when a note is deactivated. This allows for sustained notes, chords, overlapped notes, etc. The MIDI specification generates two messages on the MIDI cable for these cases exactly. When you press a key on a MIDI keyboard, a note on message is generated and sent out to other devices in your MIDI chain. When you let the key go, another message called a note off is sent out onto the MIDI cable. All the other devices in the MIDI chain learn about the fact that the note has stopped. Along with these note-on-off messages, there is a number that corresponds to the key of the note that is being pressed. Armed with these insights, it is clear that we just need a way to listen for these messages, save them, and then later play them back according to a clock of some kind. Rather than clutter the diagram with timestamp information, I chose to leave that detail out. However, if you are wondering, yes, PLP will need to pay attention to the timing of the notes to get the playback to sound correct. While there is not a lot of work to do to enable MIDI recording, it is harder than it looks based on the simple list above. The real challenge when implementing a program like this will be in how well the code can receive MIDI data from a wide variety of devices. It is not enough for me to test with just a single MIDI controller. I will have to test the system with a lot of different MIDI devices from a lot of manufacturers in order to make the MIDI input implementation bulletproof. If you happen to have a few MIDI devices and want to help with the testing, please get in touch with me via my email or DM me on YouTube. In order to divide and conquer the problem space, I will focus on monophonic recording first and polyphonic recording second. This should help establish the array structures and timing techniques and allow me to tweak rate balancing looping constructs without getting too bogged down with too much note data happening all at once. I hope you enjoyed this more technical intermediate project update, and I would love to hear from you about any questions, suggestions, and ideas you may have regarding the project. As I have said before, synthesizers are a wonderful tool for exploring sound. They allow for modes of expression far beyond spoken word. One day, I hope that Pip can add something new and valuable to our synth community. Thanks for your time, and have a great day.